Welcome back to my Let's Code series. We're coding Advent of Code 2022. And yeah, let's jump right into day 3, right? Last time we made quick work of day 1 and 2, I would say, and let's see. I hope this will be more complex than the previous 2 puzzles. Rucksack Reorganization. One elf has the important job of loading all of the rucksacks with supplies for the jungle journey. Why is there a link on a rucksack? Unfortunately, that elf didn't quite follow the packing instructions, so a few items now need to be rearranged. Each rucksack has 2 large compartments. All items of a given type are meant to go into exactly one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item type per rucksack. The elves have made a list of all of the items currently in each rucksack, your puzzle input, but they need your help finding the errors. Every item type is identified by a single lowercase or uppercase letter. That is, A and A refer to different types of items. The list of items for each rucksack is given as characters all on a single line. A given rucksack always has the same number of items in each of its 2 compartments. So the first half of the characters represent items in the first compartment, while the second half represent items in the second compartment. Okay, so for each line we always have an even number of characters, and half of them goes into the first compartment and the second half to the second compartment. Okay. To help prioritize item rearrangement, every item type can be converted to a priority. Lowercase item types A through Z have priorities 1 through 26. Uppercase item types A through Z have priorities 27 through 52. In the above example, the priority of the item type that appears in both compartments of each rucksack is... The priority of the item type that appears in both compartments, 16P, 38L, uppercase P, lowercase v. Only one item is duplicated. No, there are like 3 T's, but I think only one item is both in the first compartment and the second compartment. Is that it? 19 S, S and S. The sum of these is 157. Find the item type that appears in both compartments of each rucksack. What is the sum of the priorities of those item types? So exactly 1 item appears in both compartments. All items of a given type are meant to go into exactly one of the 2 compartments, but an elf messed this up for exactly 1 item type per rucksack. Okay, I see. So that's an assumption we can rely on, I suppose. Let's create our day 03 file and day 03 input file. Of course, we have our inputs, string slice, and also we want to have a function called parse input. And we have a test case for part 1. All right, so yeah, what does the state look like? We have a rucksack struct. We have 2 compartments. Compartment 1, which would be, let's say, a vec of strings, or actually character. A vec of characters. In compartment 2 is also a vec of characters. And parsing the input means we have a vector of rucksacks. we take the input and we need to register our module. So Rust Analyzer can pick it up. All right, input, we want the lines. And for each line, we will trim it first and get the characters. And let's collect it into a vec already, because we do need the total number of characters. So compartment size would be characters.length divided by 2. And we can return a rucksack where compartment 1 is, actually we can just do a slice characters until compartment size. Yeah, okay, we can omit the 0. And for compartment 2, it's compartment size the second half. So this is a problem. Okay, let's collect it at the end. So this is a problem because we defined it to be a vec instead of a slice. But we can just call toVec to make it into a vec. And let's test it. By printing out our parsed vector. And for that, of course, we need to derive debug on Rucksack. Okay, this did not go well. Wait, what happened? This looks wrong. Line trim, we want the characters to collect into a vec. Doesn't look wrong, actually. Why is there a space character? Where does the space character come from? I have no idea. Oh, okay. I'm getting the input for day 2. Okay, that's completely wrong. That's why it's so weird. Okay, let's try this again, shall we? Okay, this looks much better. Looks much better now. Just to make sure we don't do anything stupid, let's trim this as well. Let's trim the input. And now we just need to figure out which item is in both, right? Let's call this intersect compartments. And we can just say compartment 1, iter over it, collecting this into a hash set. Then we can intersect with another hash set, which would be compartment 2, where we collecting compartment 2 into a hash set. And we get an iterator. We just return an iterator. Item equals char. Expected 2 borrows of char. Okay, that's a little bit too much. Let's clone it. Let's clone it again. And this captures self, so we need to add this, no? Cannot return value referencing temporary value. Temporary value created here. Oh yeah, no, wait, what? I guess this is the temporary value that needs to be inside this iterator. Okay, fine. Fine, let's collect it into a hash set, I suppose. Okay. We will have a hash set of chars then. Oh, we need a conversion from chars into the score, the priority. The conversion explained here, that's the usual ASCII conversion, right? Let me Google that. I don't know that. So actually it's not the ASCII conversion, because uppercase starts at 65 and lowercase starts at 97, so that's completely wrong. So we actually need to do some transformation. And for that, let's introduce a new struct called item, which has char as a value. And we can introduce a new function from char. Char, which will return a result of either item or char as arrow type. We can do some tests. If char dot is alphabetic, I suppose. No, is ASCII alphabetic. Then we return OK and an item with the char. Otherwise, we will return error with, returning the char itself. And our compartment would be vectors of items. And here, item, we would need to derive stuff on item. Especially we need partial equality, equality, and hash for our hash set. But also we want clone. We need clone. This will give us a hash set of items. And here we would need to filter map to convert the char to item. Yeah, and we're converting our result into an option. And whenever we cannot pass the char, we will just ignore it. It won't happen anyway, but this is just to safeguard this. And we would need to add a new function called priority, which takes self immutably and returns a priority. Let's make it use64. If self.0 is uppercase, is ASCII uppercase? Well, let's do it lowercase first. Is ASCII lowercase? Then we need to subtract 61, right? So self0 is u64 minus 61, I think. Lowercase a would be what? 1. Okay, so we actually need to subtract 60. Else it is uppercase. Then we need to, if self0 is uppercase, No, is ASCII uppercase. Then the first one is 41. 41. So minus 41 plus 27. Minus 41 plus 27. Else it's unreachable. Minus 41 plus 27. Is that correct? And what do we want to do? We want to loop over all the rucksack and find the item type that appears in both compartments and get the priority summed up. Okay, let's iter map rucksack, and then we just call rucksack dot intersect compartments. Get the iter. And then we have the item here where we can say item dot get me the priority. And then we sum it up into a U64. I mean, theoretically, the intersection would only contain one item, but we can never be sure, can we? Now, if it's multiple items, we cannot use a hash set intersect anymore because the hash set will deduplicate all the items, right? Oh well, but our working assumption is there's only one item. Okay, so we have an iterator over U64 now, which we will sum up as well. And that's it. If I'm not wrong. 17,000, that's a very even number. Is that correct? Nope, that's not correct. Damn, that's not correct. What? Can't be. Intersect compartments, we get a hash set of items, and when we calculate the priority, is the priority calculation wrong? If it's lowercase, no. What am I doing? It's in. This is hex. This is of course hex representation of the number. Okay, then this has to be like this, right? Yeah. This is hex. Didn't notice it. Okay. Then what about now? 9,944. That could be it. No! No! What? Am I doing something wrong? If it's uppercase, then we need to subtract 41, right? In hex. Oh, not add hex 27 in hex. We need to add 27 in decimal. Yeah, that has to be it. 8,072. Yay! That was it. Let's move on to part 2. As you finish identifying the misplaced items, the elves come to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency, within each group of 3 elves, the badge is the only item type carried by all 3 elves. What? Elves are divided into groups of 3, and every elf carries a badge. Okay. The badge is the only item type carried by all 3 elves. What do you mean 3 elves? That is, if a group's badge is item type B, then all 3 elves will have item type B somewhere in their rucksack, and at most 2 of the elves will be carrying any other item type. I don't get it. The problem is that someone forgot to put this year's updated authenticity sticker on the badges. All of the badges need to be pulled out of the rucksacks so the new authenticity stickers can be attached. Additionally, nobody wrote down which item type corresponds to each group's badges. The only way to tell which item type is the right one is by finding the one item type that is common between all 3 elves in each group. Every set of 3 lines in your list corresponds to a single group, but each group can have a different badge item type. So in the above example, the first group's rucksacks are the first 3 lines, and the second group's rucksack are the next 3 lines. In the first group, the only item types that appears in all 3 rucksacks is lowercase r. This must be their badges. In the second group, their badge item type must be z, because all 3 elves carry z. Priorities for these items must still be found to organize the sticker attachment efforts. Here they are 18 for the first group and 52 for the second group. The sum of these is 70. Okay. Find the item type that corresponds to the badges of each 3 elf group. That doesn't sound too complicated, I think. We just need to, instead of intersecting the compartments, we need to intersect the elves. We will first parse input as usual. And then we need to iter over rucksacks. And I think there's a helper function, array chunks. Returns an iterator over n elements of the iterator at a time. The chunks do not overlap. That's exactly what we need, right? The question is, can we use this? Can we use this in stable Rust is the question. Const n. Not sure if I can use this in stable Rust, honestly. No. No. No, it's an unstable library feature. No. No. Okay. Can we use anything else? Okay, you know what? What we can do is just simply range 0 to rucksacks.length, and then we will call step by. Creates an iterator starting at the same point but stepping by the given amount at each iteration. Step by 3, right? And then map, we get an index and we can just access the index like this. So we return an array slice from I to I plus 3. We're borrowing the slice. And then we would need to intersect rucksacks. Let me implement iter, an iter function, which will return us an iterator over references of item. And we'll just iter over compartment 1 and then also chain self.compartment2.iter. That should work. We only have 3 items here, so rucksacks 0.iter.enter. Oops, we need to collect into a hash set. We iterate and collect it into a hash set, and then we need to intersect with rucksacks1.iter collect and then intersect with rucksacks2.iter.collect, and I think these need to be references. And then we will collect that into a hash set. What is happening? No method intersection on type intersection. So we need to collect the iterator into a hash set again so we can call intersection again. Okay. I guess that's okay, let's make this look nicer. I mean, okay, we can also iterate over all the rucksacks and fold it into iter and then fold it. Our initial thing needs to be an empty hash set. And we have an accumulator and a rucksack. And we need to say accumulator dot intersection rucksack dot iter collect into a hash set and then collect into a hash set. Something like this. The value of hash set item cannot build from an iterator over the type reference item. Okay, yeah, that makes sense. So somehow I did something. Let's make it copied. That should work. Now this is a problem because our initial hash set is an empty hash set. So an empty set intersected with anything else would be still the empty set. So that's not good. I guess I can use fold with none as an accumulator. And then accumulator is now an option of a hash set. So we need to map this. Map or else. Default would be rucksack.iter.collect. Otherwise, we will have the accumulator ourselves, and then we can say accumulator.intersection. And we do not know what accumulator is, so let's provide the type here. Option hash set item cannot be built from an iterator over elements of type item. Yeah, that's why we have to do it with sum. And this also needs to be sum. Okay. So now this is an iterator that returns something. That returns. Rust Analyzer is a little bit overworked here. Rust Analyzer doesn't know what the return value of this closure is exactly. Actually, we can only iter over that. Yeah, because this is a reference to a slice. This closure returns a hash set, an option of a hash set. Let's get rid of the option by using filter map instead. So this is now an iterator over hash sets over items. Then we just need to flat map, intersection. We have the intersection. We can iter over the intersection. We can even into iter. Flat map that, and then map. We will get the item here, so we can just call priority on the item. And then we can just sum it up as a U64. We will get a U64, which is our result. Batch priorities, batch priority sum, something like that. All right, this was a little bit complicated, but I hope everyone's still following. Let's run this. 2567. Let's see if this is correct or not. It is! Okay. Interesting. We can already see a little bit of what the final picture is supposed to be. We have some water / river, a canal maybe, and like a beach. I don't know. And let's move on to day number 4. Camp cleanup. Space needs to be cleared before the last supplies can be unloaded from the ships, and so several elves have been assigned the job of cleaning up sections of the camp. Every section has a unique ID number, and each elf is assigned a range of section IDs. However, as some of the elves compare their section assignments with each other, they've noticed that many of the assignments overlap. To try to quickly find overlaps and reduce duplicated effort, the elves pair up and make a big list of the section assignments for each pair. My puzzle input. For example, the following list of section assignment pairs. For the first few pairs, this list means within the first pair of elves, the first elf was assigned sections 2 to 4, sections 2, 3, and 4, while the second elf was assigned sections 6 to 8, sections 6, 7, 8. The elves in the second pair were each assigned 2 sections, 2 and 3, 4 and 5. The elves in the third pair were each assigned 3 sections, 5 to 7, 7 to 9. This example list uses single-digit section IDs to make it easier to draw. Your actual list might contain larger numbers. Visually, these pairs of section assignments look like this. Yeah, makes sense. 2 to 8 is like 2 to 8. Some of the pairs have noticed that one of their assignments fully contains the other. For example, 2 to 8 fully contains 3 to 7. And 6 to 6 is fully contained in 4 to 6. In pairs where one assignment fully contains the other, one elf in the pair would be exclusively cleaning sections their partner will already be cleaning. So these seem like the most in need of reconsideration. In this example, there are 2 of such pairs. In how many assignment pairs does one range fully contain the other? Okay. Let's get our puzzle assignment. But it's only one pair, right? We want to see if if one is contained in the other or not, I suppose. It doesn't matter if 6, 6 is, for example, contained in this one or not, right? Yeah. Okay, sounds very straightforward as well. But I bet it will get more complicated in the future. Let's make our preparations. We have our input slice and a function. And let's define a struct called range. Where we have, I don't know, how many sections are there? Not that many actually. Let's say a section is encoded by U8. And we will get a list, a vector of pairs of ranges actually. We just say lines, map line, and then we will split it up into tokens, split it, comma, have first range equal tokens next. We have second range tokens next. And we need to make sure that both ranges exist. Make it a filter map. First range, second range. Only if both are sum, we will return sum. I said if both are sum. So first range, second range. Otherwise we will return none. For the first step, let's return a tuple of the first range and second range. So this should give us a vec of tuples with string slices. Yeah, like this. And now in the second step, let's make it a filter map again. We have first range, second range. Actually, let's implement from string for range. Error, let's return an empty tuple, and then here we will say let mood tokens equals s.split at dash let's start equal tokens.next and equals tokens.next. And we also need to parse it. So let's match start and end. And we will only do something if both are sum, otherwise it's an error. If both are sum, I will return OK with start.parse parse into U8 and parse into U8. And we need to make it a range, of course. And now we couldn't convert the error into an empty tuple. That's fine. Let's error map error into a tuple. Oh. Okay, if any error happens during the parsing, we will just map the error into an empty tuple and return the error variant here. And this should be fine. And so here we will match first range.parse into a range. And second range will be parsing it into a range as well. And only if both are okay, we will return sum, otherwise we will return none. We will return sum with a tuple in it, first, second. And of course, tokens must be mutable, so we can call next on tokens. And collect should be collecting into a vector with tuples of ranges. That's all right. Part 1. Let's call it schedule, equals parse input of input And we will debug print schedule. So we see if everything's parsed correctly. Of course, as usual, we need to derive debug for that. Okay, it's not parsed correctly because we used the wrong input file. Okay, here we go. Looks good enough. Okay, now we need to implement some methods on range. Especially, we need a function that can tell if a range is contained in another range or not. Let's call this contains. Other would be a range as well. And we will return a boolean. So what means if a range contains another range? It means, of course, we also need access to self. It means self.0 is smaller or equal other.0. And self.1 is greater or equals other.1. That's all it is, right? So what's the question? How many assignment pairs does one range fully contain the other? So to answer this question, we will iter over our schedule and filter out range 1, range 2. We will filter out all those pairs where range 1 contains range 2. Range 1 contains range 2 or range 2 that contains range 1. Filter that and then get the count. That should be it, 483. Yeah. Part 2. It seems like there is still quite a bit of duplicate work planned. Instead, the elves would like to know the number of pairs that overlap at all. In the above example, the first 2 pairs don't overlap, while the remaining 4 pairs do overlap. 5 to 7, 7 to 9 overlaps in a single section 7. 2 to 8, 3 to 7 overlaps all of the sections 3 to 7. Yeah. So in this example, the number of overlapping assignment pairs is 4. In how many assignment pairs do the ranges overlap? That's an interesting question, and then we can just answer this by adding overlaps method onto range and returning a bool. And when will these overlap? It means self.1 is greater or equal other.1, or self.0 is smaller or equal other.0, right? No, wait, that's completely wrong. No, if the end of self is greater than... If the end of self is greater than the start of other, okay, that makes much more sense. Or if the start of self is smaller or equals the end of the other range. Is that true? Hold on. So let's say we have 0 to 7 and 5 to 10. Obviously, these overlap. So if the end of self is greater than the start of other, which is this case, or the start of self is smaller than the end of other, which is also the case. Wait, hold on. What about the other order? We have 5 to 10 and 0 to 7. Then this also is the case, right? The end of self is greater than the start of other. So this doesn't make any sense. What am I even doing? So either we need to sort them first, or we can say self.0 is smaller equals other.0. Then they will overlap if the end of self is greater than the start of other. Or if self.0 is greater than or equals than other.0, then other will come first, then the end of other, if that's greater than self.0, then they're overlapping, right? So in this case, we are in the first case, and 7 is greater than 5. So in this case, 5 is greater than 0. So we check if 7 is greater than 5, which is exactly what we need to check out. Okay, so what about 0 to 3, 4 to 6? Then we're in the first case, and 3 is obviously smaller than 4. Okay, what about -1 to 6? I mean, there's no -1, but let's just hypothetically speaking, okay, let's make it the 1 then. 1 to 3, 0 to 6. Then we're in the second case, and we need to check the end of other if it's greater than 3, which it is. I think this should be correct now. I really should write more tests, but we only have this much time. As for part 2, instead of using contains, we can use overlaps. And then we have 174. Should be correct. Yes, it is. Oh, what is that? Some kind of tents? Maybe? I mean, the green thing is maybe the woods, the jungle, and they're setting up camp in the jungle. Makes somewhat sense, I guess.